G'day lads, a little bit of year 10 trigonometry today. It's going to be an interesting one. It's the first time I've given you guys new content via distance, so hopefully this goes all good. I've got 3 right-angled triangles here, and I don't know the angle, so I'm going to be trying to find the angle theta, which is measured in degrees. Now, most of our steps are all the same going through this. The first thing we do is we label the sides in question. So, if I was to label this side here would be the opposite, an O. And this side here, remember that right angle points to that long side. So that is the hypotenuse. There's a longer side of that right angle triangle. And I think to myself, well, what rule must I be using? And so I have a look at SOHCAHTOA, just a mnemonic to help me remember the rules. So I'm looking at a rule that has O and H, or I'm looking for a rule that doesn't use A, and it's that one there, right? O and H, so it's the sine rule. So if I was to write out the sine rule, I'd know that if I took sine of that angle theta, it would be the opposite over the hypotenuse. That's the sine rule for us, right? If I decimalize that angle using sine, it would be the same as taking the opposite and dividing it by the hypotenuse. Next thing I do is I look at what that might look like with numbers. So I take sine of theta, because I don't know that angle. That is the same as having 3 divided by 5. And now I can see where you lads might get a little stuck. Well, how do I figure out what that angle is there? And it's just a little trick. So on your calculator, you would have seen that you have a sine, cosine and tan button, but above there's these little yellow ones where it's sine to the -1, cosine -1, tan -1. Now those are inverse functions. I'll show you what that does. If I wanted to have theta by itself, then I do this little trick. One little easy trick is I cancel the sines on both sides, and I have sine inverse 3/5, and that's my working. So if you were sitting an assessment, you get one tick for that, you get 1 tick for that, and your final tick will just be getting the answer. I'm going to show you how that's done. So on this calculator, so I turn it on, I just need to make sure I'm in degrees, and I am. So if I was needing to change it, okay, shift, set up, and if I was I needed to be in degrees, I'd hit 3, and there I am. I'm in degrees now. So if I need the sine inverse, I shift, sine, and that gives me the yellow one. Shift gives me any of these yellow symbols. So shift, sine, and it brings a bracket up already. All I have to do now is 3 divided by 5, close that bracket. I have to close that bracket so that it doesn't divide the whole thing by 5, but only divides the 3, equals. Now I've got about 36.9. So theta is 36.9. And remember, you need to go back and make sure that you're going to get your units right. Now there's no units on this, but it is an angle. So it's 36.9 degrees. If that was clear, you might want to just go ahead and do these two, and that would be your third and final mark for that question. So it's just one little trick. If you want the angle, you plug in these numbers and you just sine inverse, or just do inverse of the trig function. So let's have a look at this one here. First thing we want to do is label our side. So that's the opposite side to our angle. It's completely opposite that angle. This points to our hypotenuse, and so this one is our adjacent. It's right next to the angle. So in our mnemonic, what are we going to be using? Well, it's tan, isn't it? It's the opposite and adjacent. So we just write out our rule. where tan theta is the opposite over the adjacent. There's our TOA, T-O-A. That's our relationship. So now, I actually don't know theta, so it stays as theta, but we know O is 6 and A is 8. 6 and 8. And so when we don't know the angle, we just go to this next step, where theta is tan inverse of 6 over 8. So let's have a look at what that looks like. Shift tan, right, there's our tan inverse. 6 divided by 8, just treat that as a division. 6 divided by 8. Close that bracket off, equals. Wow, pretty, it's the exact same angle, isn't it? Interesting. That's just a coincidence. That is 36 point, if we're going to 1 dp, which is usually pretty standard with degrees, we would have 36.9 degrees. And if this was being marked, there's a mark, and there is another mark. Awesome. So, like everything, trig functions have an inverse. So, addition and subtraction are inverses. Multiplication, division are inverses. Squaring something and square rooting something are inverses. And so sine has a sine inverse, cosine has a cosine inverse, and tan has a tan inverse. Everything has an inverse, and so we can undo this with our inverse trig functions. It's really simple, right? You don't know the angle, tan inverse it, sine inverse it, depending on your relationship. So let's label this one up. I have O, and here's my hypotenuse, and this is my adjacent. So again, it's tan again, isn't it? So we can write out our relationship. Tan theta, if I decimalize that angle with tan, that's the same as going 13 over 3. Right, the opposite over adjacent. So now I want to rearrange for theta, and so I just inverse this function here. So theta is tan inverse of 13 divided by 3. So let's have a look at that. So shift tan gives me my inverse, the yellow one, and that's 13 divided by 3. Close that bracket up. I don't want to divide everything by 3, just that 13. Equals, and that is 77, 1 dp, 0.0, right, there's 3 significant figures there. Sorry, that's just going to one decimal place, and that is degrees. So you would get a tick for that, a tick for that, and a tick for that, and I hope that has been made really clear. 1, 2 steps, and an answer. And just, I'll show you one more time. To put your calculator degrees, shift mode, and if there's an R there, you need to go shift mode and just put into degrees 3. And you're away. Awesome. There you go, lads.